Hi, so today we talk about how to use the Cramer's rule to solve the simultaneous equations in two variables. So we are dealing with Cramer's rule now to solve two equations or rather simultaneous equations in two variables. Now let us take a simple example, or rather let's take two simple equations. Say 2x plus 3y equal to 5, and another equation, say x plus y equal to 2. Now how do we solve these two equations? Okay, equation 1 and equation 2 using Cramer's rule. Now first of all, we know that Cramer's rule is related to determinants. Okay, so we first prepare the determinants of the coefficients of x and y. So we have 2, next is 3, where coefficient of x is 1 and y is also 1. Okay, now let's evaluate this determinant. So 2 times 1 is 2, 1 times 3 gives 3, which is how much? Minus 1. Remember, the value of determinant d should not be equal to 0. If it is 0, then we cannot apply the Cramer's rule. So here that's not an issue. Next is we prepare the determinant for the variable x, so we denote it as dx. Now again it's very simple. Now which were the coefficients of x? 2 and 1. So remove the column of the variable x and just replace it by 5, 2. So 5 and 2 just come here, right? So remove 2 and 1 and just put 5 and 2 in the column of x. Now 3 and 1 would remain the same. So dx basically means d by replacing the x column. Okay, d, you replace the x column by the constant, that is 5 and 2. Now let us evaluate this. So 5 1s are 5 minus 3 2s are 6. So again you get a minus 1. Okay, next would be dy. Now dy, it means you replace the y column in determinant d. So 3 and 1 would be replaced now by 5 and 2. So x column remains the same and y column you just put 5 and 2. Now evaluate this. So you get 2 2s are 4 minus 5 1s are is 5. So again you get minus 1. Now once you obtain these three determinants, we simply apply the Cramer's rule. So it's very easy. So by Cramer's rule, x would be dx divided by d, which is, how much is dx? Minus 1 upon minus 1. So the value of x is 1. And the value of y would be evaluated as dy upon d, which is again minus 1 upon minus 1. So the end result is again 1. So this is the solution of the two equations.